Good morning, friends. I am Yuvraj and today I am going to teach you about motion. Here it is our content. In content, motion, physical quantities, type of motions, measuring the rate of motion, rate of change of velocity, graphical representation of motion. Now, motion. Before understanding of motion, we have to understand types of states. In this universe, there can be only two types of state. First one is rest. If any object is not changing the position with respect to a stationary reference point, then it is in rest. For example, with respect to your screen, you are at rest, and with respect to your screen in your room, if fan is running, then fan is in motion, because fan is changing its position with respect to your screen. Hence I am emphasizing the word stationary reference point. Why? Look at this example. Mr. A is on ground and Mr. B is on moving cart. With respect to Mr. A, Mr. B and cart both are in motion, but with respect to Mr. B, the cart is in rest. Hence, to get clear understanding of states, we have to choose stationary reference point. Next, physical quantities. In motion, some physical quantities are involved. Physical quantities are nothing but physical property of material that can be measured. It has two types. First one is scalar quantity. Scalar quantity requires only magnitude, and second one is vector quantity that requires magnitude as well as direction both. Example of scalar quantity are distance and speed, and the examples of vector quantities acceleration, displacement and velocity. We will learn these physical quantities in next slides. In this example, we can see a square is changing its position A to position B and taking one time to reach, and position B to position T another 1 minute, position C to position D another 1 minute. So here we can see the actual part traveled by an object is called distance, and total distance traveled by square in 3 minutes is equal to 420 meter. And displacement is nothing but it is shortest distance between initial position and final position. And here in this example we can see from achieving position A to position D, it took 3 minutes, and total displacement traveled, total displacement is 140 meter, and it is as vector quantity. Hence we have to show its direction, and it is towards its direction. With this example, we can see the difference between speed and velocity. Speed and velocity are physical quantities. Speed is nothing but it is distance traveled per unit time, and its SI unit is meter per second. And velocity is nothing but it is a vector quantity, and that is displacement with respect to time, or displacement per unit time. Hence in this example we can see total distance traveled by this square is 420 meter in 3 minutes, that is 180 seconds, and so the speed of this square is 2.33 meter per second. Similarly, velocity, displacement traveled, displacement covered by the square is 140 meter towards east in 180 seconds. Hence the velocity will be 0.77 meter per second towards east. East is showing the direction, hence it is a vector quantity, so it is must to show the direction. Average speed and average velocities are another physical quantities involved in motion. Average speed is nothing but it is the ratio of the total distance traveled by the object to the total time of journey. It can never be zero, while average velocity is the ratio of displacement to the time taken in entire journey when the velocity of a body moving in a particular direction changes with time. Average velocity of a body may be zero even if its average speed is not zero. In this example we can see, look at this table, just we are getting all the physical quantities at each position A, position B, position C, position D, in which we are getting distance traveled, displacement traveled, average speed, average velocity at every position. Now, types of motion. There are two types of motion. First one is uniform motion and second is non-uniform motion. In uniform motion, the object travel equal distance in equal interval of time. But in non-uniform motion, body travels unequal distance in equal interval of time. That means from this example we can look in each interval, each unit of interval of time. In uniform motion, the blue car is traveling 10 kilometer, while in non-uniform motion, purple car is traveling non-uniform distance in equal interval of times. And here it is representation of distance and time graph. Here we can see a straight line showing uniform motion, while the curved or non-straight line shows non-uniform motion. Acceleration is nothing but it is change in velocity with respect to time. In this example, we can see that acceleration of the car is 1 meter per second square and its initial velocity is 4 meter per second. That means velocity of the car is going to increase by 1 meter per second in every next second. So from this table we can see at t equal to 0, initial velocity is 4 meter per second. In another 1 second it increases by 1 meter per second and becomes 5 meter per second. At t equal to 2 seconds it becomes 6 meter per second, and that is accelerating body. Velocity is going to increase with respect to time. It may be positive, it may be negative. Negative acceleration is called deceleration. It may be 0. Still the body is moving. If acceleration is 0, then the velocity of the object is constant. There is some graphical representation of motion. In first graph we can see velocity time graph. In first 2 seconds the velocity of the object is 0, and from second to 4th second the